So we will concentrate today on the Thingy 91 of NORDIC's semiconductors device, which is a kind of a platform to develop embedded systems containing sensors and all this stuff. So it's much more than only a communication module. And so we will explain how to attach this to the network, how to register this to the IoTCREATORS platform, and to send uplink messages, downlink messages, and to see how this data can end up in an application. We already had an introduction. So we will start some words. What is IoTCREATORS? So for many people, they have a big question mark about what is IoTCREATORS, because we are on the one hand side, we do some technical stuff, we do some communication stuff, we do community stuff. So I will say some words to what is IoTCREATORS. Then we will have our live demo together with Kevin. So Kevin will show how to handle this device. Together with me, I show how to handle the backend. Kevin shows how to handle the device. And last but not least, we will have a sample to explain how a real-world scenario could look like sending the data to AWS IoT Core. So what is IoTCREATORS? So IoTCREATORS is not only a system, it's not only a group of people, so it's more or less both. And the intention is that we integrate devices, IoT applications, on one hand side, on the other hand side, the people who has to deal with this. As you know, people working with embedded devices, they have completely different kind of challenges in the area of IoT, like the people who are working with the business applications or the IoT platforms. So we like to bring them together on the technical layer, but also on the community layer, on the people layer. So on one hand side, we integrate all the different types of narrowband networks, IoT networks, which are narrowband, LTE-M, and LoRaWAN currently. There's a little bit of Sigfox, of course, but for some reasons, Sigfox doesn't appear in our presentations. But anyhow, so we integrate narrowband IoT, LTE-M, and LoRaWAN on one hand side, and on top of those, especially on narrowband IoT and LTE-M, we have the IoT protocols. Regarding the IoT protocols, life is very easy for LoRaWAN because there isn't any kind of standard, because the way how to transport the data from the device into the LoRaWAN network server is already specified, so there are no questions about this. That's a kind of open domain in the narrowband IoT and LTE-M area. That's why we have to deal with UDP, CoAP, MQTT, or lightweight M2M. So those things are integrated by our SCS component and populated through our northbound API to the application or IoT application layer. This is a system view to the whole story. But of course, we want to integrate. As you can see, we have a forum to support the communication between all the different stakeholders. We have also a documentation library in which we share all this information. But you can see here in this picture, IoT is not only a technical challenge, it's an integration challenge. Integrating systems, integrating data, integrating people. So if we look to the IoTCREATORS, this is what the end user can see through the internet, through the portal. We have more or less 4 different access points. Of course, we have the IoTCREATORS.com, the homepage, where you get all the different types of information. We have our portal, in which you can do, of course, the kind of device management, a little bit of SIM card management, but also where you can order SIM cards, connectivity, and the devices which you like to manage. We have our forum, in which the community can ask questions and gets answers. And last but not least, we have our documentation library to share all the information, information about the mobile network itself, which are always required by the developers, especially on the embedded side. And also we have information about how to integrate different types of systems, always in the IoT domain. We want to spend most of the time in explaining how to integrate, how to handle the Thingy 91. We will show you first some slides about what is the device about, and after we explain this, we walk through the practical use case.
Thank you, Roland. Thanks again to be here on the stage. A few words before we start with the live demo on the Thingy 91. So the Thingy 91 is a Nordic, as Roland said, prototyping platform, rapid prototyping platform. It is built around our NRF 9160. That's the actual cellular modem. But the interesting part around it is that it's actually not a pure cellular modem. It comes with a application core or with the ARM Cortex microcontroller built in as well. So you can build your logic, or whether it's your final firmware of your product, into that same chipset. On the Thingy 91, the good thing about it is, as you can see it as well here on the slides, we have a modem, a cellular modem supporting NB-IoT, LTE-M, and a GPS receiver on board. We have as well the NRF 52840. That's one of our Bluetooth low energy socks on the device. So you could also create a Bluetooth gateway or connect other types of sensors via Bluetooth low energy to that Thingy 91. Then another good point is it comes with a SIM card. So when we ship that prototyping platform, actually all you need is a USB, a micro USB cable, and plug in that SIM card and you're good to go. You can program your device, you can use it standalone, it comes with a battery, and you can just, actually this one is, we'll see it at the end of the demo, is currently running and transmitting temperature data all the time to the IoTCREATORS portal. As I said, various sensors. This includes temperature, humidity, a gas resistance sensor. We have an accelerometer sensor as well. And I think it's an interesting gadget to get started. This is a more closer look on the hardware. Most of it, I said already, it's fairly tinily built. This is our main modem here, as I said, the NRF 9160. The NRF 52840 is our Bluetooth low energy solution. We have all the antennas on board. We have a SIM card holder that is for nano SIM cards, or used for nano SIM cards. Then on the peripheral side, what you can use and what you can develop or get your own ideas coming with is various sensors, also light sensors, a buzzer where you can make some noise or some basic tones. And technically you can also connect some other lights or bigger applications and switch them on and off using just MOSFET transistors. And there's also an LED that you can light up in different colors, basically. Okay, so I think that's that's basically what we from a Nordic perspective usually demonstrate or tell customers on how to get started. Nordic itself, we feature as well a cloud solution, that's the NRF Cloud. And you can plug in the SIM card, add a new device on our NRF Cloud, and get started with your Thingy 91 and see basically all that sensor data. Our Thingy 91 comes shipped with a pre-compiled firmware and application firmware. So it's the startup time should be within 10 minutes, technically, if the network and everything coverage is good and you're good to go. And on another note, but I know that IoTCREATORS also has a very good get started guide with the Thingy 91, and that's of course also of good help if you want to connect to your cloud system, whether it's NRF Cloud or the IoTCREATORS Cloud.
As next, we will go for the live demo. We will show how to register the device on the platform, the IoTCREATORS platform. Actually, this will be done by me. Then we will show how to attach the device to the network, send a message, and then we will see the message in the platform, and we'll probably do a hooray. Then we will show you how to register a simple, super duper simple application endpoint in the Bceptor environment, and again send a message to see that the message is forwarded. So the Bceptor is just a simple example for your application. And last but not least, we will show you how you can send downlink messages from the platform to the device. In the IoTCREATORS portal, you can see you have different areas. You have projects. Of course, you have orders, because you can order SIM cards, you can order device management items. And you have configuration items, settings. You have a link to the documentation, and you have a link to the forum. So we look to the projects. Devices are managed within a project. And of course, we want to register the device, for example, the standard UDP demo project, which we created before. To save time, we already registered the device with which we will work now. It's actually this one. But I show you how to register another device, which is pretty simple. As you can see, registering a device, you need to make a decision. You need to know with which protocol your device is communicating. And as I said before, in the IoT domain, you have raw UDP, you can have a co-op, you can have MQTT, but you also can have LoRaWAN, for example. So if you have a LoRaWAN device. And so, for example, we would now register a UDP device, and we would input a valid EMI. Yeah, some kind of valid EMIs, and so on. And this is really, actually I like this feature very much. You can add, to each device, you can add uplink message tags, which is it can be really important, because if you receive the data of the devices in your application, and if you have different types of sensors, different type of devices, which have different data formats, you need to know from which type of device the data comes from. But here, for example, you can add any fields of your choice, like, for example, device type. Like thingy 91. And of course, with each message, with each uplink message, which is forwarded to your application, at the end, you get this information. And you can use this. So it's quite useful. Anyhow, what we did this already, and we ended up with this device here. And now the system is ready that we can go to the device, attach to the network, and send a message. And this would be done by Kevin.
Basically, a few words on that term IMEI. I don't know how familiar everyone is with that term. It's a unique identifier for the cellular modem. So every cellular end device that connects to the network has its unique IMEI. And that makes sure that, well, your device that you're having in front of you is the right one and the correct one to register or to connect to the network. And on the Thingy 91, for example, there's a label. Once you open that Thingy 91, I think it's also printed on the boxes on the outside, yes. And even though if you have thrown them away, there is always a standardized AT command that helps you to retrieve that number, because that's what you, at the end of the day, need, right? Yeah, exactly. What I have here is already a Thingy 91 connected. I mean, you may want to update the firmware on your device, on your Thingy 91 when you receive it, but that's optional, or that depends when you bought the device or when you received the device. Mine is now up to date, and the LTE link monitor is what we can see here now. That's a NORDIC terminal, just a serial COM port terminal that helps, or that allows me to send AT commands, technically also other commands, but we'll use it for AT commands. And I'm basically right now interfacing or talking to the Thingy 91. And the first thing we'll do is we will check through a command that NB-IoT is basically activated. So that's a NORDIC proprietary command, but it basically tells you, the first parameter tells you whether LTE-M is activated or not, and the second one is NB-IoT activated or not. I won't go through in detail through all the parameters now, but for this device, it basically says NB-IoT is activated and all other technologies are not active at the moment. What we'll do now is I will activate registration information, so I, as a user, get to know information on when my device registers to the network or is is seen by the network. Currently, so that you are aware of that, currently this device is basically in the airplane mode, just as you know it from your cell phone. You can put the device into a cellular off state and it basically doesn't transmit any signal. Okay, next step is what we specifically need for the IoT creators. Hub is a specific APN, that's your data endpoint, to make sure when we send data or when we connect to the network that we are sending the data to the right endpoint. So in that case, Roland, right, you gave that. There are, as far as I know, different options depending on the SIM card. Is that correct? There's a SIM card from the Netherlands and a SIM card from Austria.
That's correct. So, but the SIM card which you have, you need to need to know the APN, no?
Yeah.
Okay.
So
CDP
is that so? And the guests, they will know that when they get a starter kit and when they receive their SIM card, they know they have a label there. This is your APN, or how does that usually work?
You get this information from the documentation library on the internet.
Okay, good. So in any case, you basically need that little string here. It says cdp.iot.t-mobile.nl. That's the APN, and I'm basically configuring that now to be used when I want to attach to the network. Every AT command is also responded with an OK if the command was successful. That's what we see here. So now that APN is active, and what my next step is, I will activate the modem in terms of I will leave the airplane mode. And right now it's basically searching for cell towers. So that little device here, looking for a cell tower connection, and this is already my information. That's what I activated before, that I'm connected. That's just a parameter one has to get into and understand all these different meanings, of course. But basically it says we are now registered on the network, roaming, because it's obviously a SIM card from the Netherlands and we are in Germany. And these are cell tower information if one is interested in that. Okay, so we are attached, we are registered. Next thing is we want to send an uplink message, right?
Yes.
Okay. So for that, all I need to do, it's fairly simple. I create a UDP, or I open a UDP socket. Oh, that's of course not good. Error. Let me check. Are we connected? Cops, yes, we are. 1 second. Maybe there's still a socket running from my last session. Yes, there is. So I'll just close that one for now and open it again. That's why. Okay, so we have. So yeah, I had a UDP socket in my case already opened, just because I'd used the Thingy 91 before to test and send some data. In your case, you just have to send one command, which is the last one. And all we need to do now, once that socket is open, is a fairly simple command that includes basically, so the socket defines that we are using UDP. You don't have to do that anymore. And then all we need to do is we enter the destination IP address, the port, and at the end of the parameter also the data that we're going to send. In that case, hello world is good, or hello from Rubrom, or what do we want?
Hello world is perfect. Maybe.
No, we do something else. We're different today. So we'll just send out this, and there we go.
Cool. Maybe let me say 2 words to security, because maybe you might just recognize that we didn't do anything regarding username, password, and all this stuff. We just connected to the network and sending messages to our server. That seems in the first step a little bit strange, but there has been actually security involved in it, because the security, the authentication of the device is done by the SIM card. We set up a private network, means no one else than a person having such a SIM card and having for example, the pin for the SIM card is able to access the network. And by this, no one else can send data to our servers. And of course, by knowing the IP address, we know the SIM card. By this, we also know the person who owns the SIM card. And this is, from the security perspective, quite secure. It's secure. So that's why, and this is a kind of the beauty of doing these things together, very close together with a mobile operator. Because by this, you don't need to think about on the device level, here in the firmware, about a username, a device name, and a device token, and bringing security stuff from the backend side to the device, because everything is done with a SIM card. That's the reason, just as a comment, because this was the first thing when I got in touch with this the first time, I had a big question mark. What's about security? So I think this is quite important to understand, because I think this makes life much, much more easy on the device side, especially for the manufacturers. Normally, you need to think about if you have a kind of bootstrapping mechanism, you have a specialized firmware which connects to a specific server and do security, or you even have to bring a token and the production on each device differently. And this creates a lot of effort and complexity in production processes. So that's why this mechanism is quite easy, quite nice.